Good afternoon, everyone. I am Rizal Impandiling, and my topic is particles and antiparticles. Antimatter is made of antiparticles, which are like the mirror image of normal particles. They have the same mass but opposite charge and other properties. In 1928, Paul Dirac predicted particles with the same mass as electrons but opposite charge, leading the discovery of antimatter. Every particle has an antiparticle. Antiparticles have opposite charge and opposite baryon, Lipton, and Strange's number. Example: electron has a negative charge while the positron has a positive charge. So annihilation happens when a particle and its antiparticle meet. A particle is normal matter, for example, an electron which has a negative charge. An antiparticle is its opposite. For example, a positron which has the same mass as an electron but with a positive charge. When they meet, they annihilate each other, meaning they disappear as matter. Their mass is converted into energy. In the diagram, it shows electron and positron annihilation. The blue arrow represents as an electron with a negative charge. The pink arrow represents as an positron with a positive charge. They move toward each other. So in the middle, that's when annihilation occurs. When the electron and positron collide, annihilation occurs or happen. Their mass are converted into energy. The energy is released as two gamma ray photons that wavy arrow represents. Two photons are produced to conserve energy and momentum. The photons move in opposite directions. A photon is a particle of light that carries energy in discrete packets. As proposed by Max Planck, who suggested that light is not emitted continuously but in tiny chunks called quanta. The energy of a photon is given by the formula E is equal hf, where E is the energy of the photon, h is Planck constant, and f is the frequency of the light. Since the speed of light is equals the frequency times wavelength, we can also express the photon's energy in terms of wavelength as E is equal hc over lambda, showing that photons of shorter wavelength carry more energy. Pair production is the process where energy is converted into mass. A very high energy photon or a high energy particle collision produces a particle and its antiparticle, which is the opposite of annihilation. And this can only happen if there is enough energy to create their masses and conserve momentum, usually with the help of a nearby nucleus or another particle. In the diagram, the wavy line represents a high-energy photon. The interaction point shows where the conversion occurs near a nucleus, and the two arrows moving apart represent the particle and antiparticle created and flying off in opposite directions to conserve momentum. We have three examples of reactions. The first example, there are two protons collide. After the collisions, there are four particles. The two original protons, one newly created proton, and one antiproton. The antiproton is the antimatter partner of the proton, and it is created together with the extra proton so that conservation laws are satisfied. The second example, there are two protons collide with high energy. After the collisions, it creates a positive pion and a negative pion while the original protons remain. The extra energy from the collision creates the particle and antiparticle pair. So, the third example, there are two protons collide with high energy. After the collision, it creates a neutron and antineutron, while the original proton remain. The collision energy is converted into the mass of new particles.